Welcome back to Knowledge Hub. Why does the sun not run out of oxygen as it burns? The sun does not run out of oxygen for the simple fact that it does not use oxygen to burn. The burning of the sun is not chemical combustion. It is nuclear fusion. Don't think of the sun as a giant campfire. It is more like a giant hydrogen bomb. In standard carbon combustion, carbon atoms in the fuel move up close to oxygen atoms in the air and bond together to make carbon dioxide and carbon monoxide. At the same time, hydrogen atoms in the fuel bond with oxygen atoms to make water molecules. There are often other chemical reactions occurring in a carbon-based fire, but the combustion of carbon and hydrogen atoms are the main ones. This combustion releases energy which we experience as the heat and light given off by the flame. Most of the fires that we see in everyday life are carbon combustion. Campfires, oven flames, candle flames, barbecue grills, forest fires, gas furnaces, gasoline burning in engines, etc. The key to remember is that carbon combustion requires oxygen. As soon as there is no oxygen left, carbon combustion stops. In nuclear fusion, the nuclei of atoms are fused together to make new, bigger nuclei. Since the nucleus of an atom determines what the atom is and how it behaves, a change to the nucleus causes the atom to become a new element. For instance, two hydrogen atoms fuse together to make one helium atom. Nuclear fusion does not require oxygen. In fact, you don't need any other material at all. You just need enough pressure or heat to squeeze the nuclei of the atoms close enough that they overcome their electrostatic repulsion and bond into a single nucleus. In a nuclear fusion bomb, the intense pressures and temperatures are provided by other bombs. In a tokamak nuclear fusion reactor, the intense pressures and temperatures are provided by magnetic confinement fields, by the insertion of electromagnetic waves, and by the injection of high-energy particles. In stars, the intense pressures and temperatures are provided by gravity. A star has such large mass that the gravity created by this mass crushes the star inward enough to ignite nuclear fusion. Nuclear fusion in stars releases immense amounts of energy, which we ultimately experience as sunlight. The energy released by fusion also helps sustain the nuclear fusion reaction. Our Sun has a core temperature of 16 million Kelvin and a core pressure of 25,000 trillion newtons per square meter. The Sun gets so hot from its nuclear fusion that it glows and emits light, just like how a piece of metal glows red if you heat it up. There are two main forces at work in nuclear fusion: the electromagnetic force and the strong nuclear force. The repulsive electromagnetic force between positively charged nuclei is long-range but relatively weak, while the attractive strong nuclear force is short-range but strong. When two nuclei are far enough apart, the repulsive electromagnetic force dominates, holding the nuclei apart. As the two nuclei get closer, the electromagnetic repulsion gets stronger and it gets harder and harder to push the nuclei together. When the two nuclei get close enough, the attractive short-range nuclear force dominates and the two nuclei stick together to form a new nucleus. For this reason, it takes a lot of pressure to push nuclei close enough that they fuse together. In principle, any two nuclei can be fused into a single nucleus. However, it is the easiest to fuse, and the most energy is released from nuclei that have little electromagnetic repulsion because they have little electric charge. The nuclei with the least electric charge are the lighter elements, such as hydrogen and helium. In stars, most of the fusion taking place is hydrogen fusing with itself or with other light elements. Since gravity is what provides the pressure to ignite nuclear fusion in stars, and since gravity is caused by mass, all you need is a big enough mass of hydrogen in order to end up with burning stars. There is very little oxygen in stars. The oxygen that is there was created by hydrogen fusing repeatedly until it made the oxygen. Thanks for watching.